All right, so trying to solve for problem 7, what you need to first do is try to figure out what type of a graph you're going to be doing. And for this, we are just heating up water, and so you are dealing with a graph that looks like that. Now, when you're dealing with the heating up of water and you're just heating it, you're going to be solving for Q equals mc delta T, or MCAT. So I know I need to solve for or know all of my variables except for one of them. So I'm going to write down C and I'm going to write down delta T. All right. In this problem, it tells us what Q is, and it says that Q is 130 kcals. And a kilocalorie is a form of an energy unit, just like joules is. Calories are just the unit that we use in food. So for right now, I'm going to write down 130 kcals. Okay? If the same amount of energy were transferred to 2,500 grams of water, so that would be my mass, at 27 degrees Celsius. And then it says, what would the final temp be? So I do know that it's liquid water. So looking at my sheet, I know that it's 4.18 joules, grams, degrees Celsius. And I don't know my delta T, but I do know the formula is final minus my initial. And so my T final in this case is actually what I'm trying to solve for. And my T initial is what was given to me, which was 27 degrees Celsius. So now what I want to do is I want to plug what I'm given into an equation. The problem is if you look at this C value right here, the C is in joules, grams, and degrees Celsius. Right now my energy unit is in kilocalories, which is not joules. My mass is in grams, so that's good. And my degrees is in degrees Celsius, or my temperature is in degrees Celsius, so that's good. But the problem is my heat, or my energy, is not in joules, so I need to do a conversion, right, before I even put into my Q equals MCAT. So I'm going to solve for this, and I've got 130 kilocalories. I know I need to solve for kilojoules, and the reason why I need to do kilojoules is because the only conversion I have is from kilocalories to kilojoules. So I'm going to set up a proportion, and I know that 1 kilocalorie is equal to 4.18 kilojoules. And you need to make sure that if kilojoules on the bottom, kilojoules on the bottom on the other side. So when I cross multiply this, I get 543 4 joules. All right, 3.4 joules. Kilojoules, I apologize, kilojoules. Which, knowing my another proportion, because I need to be in joules, once again, I'm going to figure out X joules, and that is equal to 1 kilojoule. Remember, any prefix of a kilo is going to be 1,000 of your base units. So 1 kilojoule will be equal to 1,000 joules. So when I cross multiply this, I get 543,400 joules. Okay? So I had to do all of that work just to figure out that my Q originally is 5,430 joules. All right. So I rewrote this for my Q. I rewrote the 500,043. I apologize for saying it wrong every single time. 400 joules. So now I'm ready to plug it into my formula. So I've got 543,400. That is equal to my mass, which is 2,500, times my C, which is 4.18, times my final minus initial. So my final is what I'm trying to solve for, and my initial is 27. Okay? Now I like to condense as much as possible, so I'm going to multiply those out. So I end up with 543,400 is equal to 10,450 times X minus 27. I personally like to design, that should be a minus, sorry. I personally like to divide by the 10,450 at this time. So in the end, I get 52 exactly equals x minus 27. So then I add 27 to both sides and I get 79. So my final temperature would be 79 degrees Celsius. So what that means is that if I had an input of 543,400 joules, I would be able to raise 2,500 grams up to 79 degrees Celsius.